So, one more time, hello. I hope you had a great lunch, and let's wait more people. So I'll speak slowly, but the most interesting information will be at the end of presentation. So, a couple of words about Bitfury. My name is Alex. I'm responsible for software division in our company. Bitfury is a leading full-stack blockchain provider. We are on this market since 2011, so over 7 years. I told full stack because we have both hardware and software division. In terms of hardware, Bitfury produces ASICs for mining bitcoins, also big containers and data centers. And in software part, we have been developing for 3 years different software solutions, such as Exonum framework for private blockchain. Also, we're working on Lightning technology. I think some of you know about it. And several months ago, we launched Crystal. It's a tool for data mining of Bitcoin blockchain. I think you know what is blockchain. Let's just check who knows what is blockchain. Great, people know. And what is your favorite blockchain? Just what kind of blockchain do you know? Bitcoin, great. Great. Yeah, Ethereum, Emercoin, there are many great blockchain solutions. And today I want to focus on challenges, because I hope everyone agree with me that currently blockchain is still on early stage of adoption. That's why we have some challenges, and we should solve it. First of all, if we are talking about public blockchain, it's scalability. The throughput of Bitcoin blockchain is approximately 10 transactions per second. Ethereum higher, up to 100 transactions per second. But nevertheless, it's not big enough for big government or enterprise solutions. Transaction speed. Also, I think you know that you need to spend some time just to for transaction proceed. And the last point is data availability. And today we'll share how we see how we can solve these challenges. So I want to start with the Exonum project. As I mentioned, Exonum is a framework for private blockchains. Why did we decide to do it? Because we understood that government and large enterprises probably cannot use public blockchain because of all these challenges which I mentioned. It's like throughput, it's like unpredictable costs per transactions, because you know that this January transactions fees for one transaction in Bitcoin blockchain was approximately $50. So Exonum provides 5,000 transactions per second, so like a private blockchain. Transactions fees in Exonum is predictable because you don't need proof of work mining, so it's not a public blockchain. And if you build some big project based on blockchain, obviously you need a budget, and obviously you need to predict your cost. And Exonum allows you to understand how much money you need to support your system. Transaction speed problems also, Exonum as a private blockchain solve it. So we provide a big number of transactions per second, and also you need just less than 2 seconds for one transaction. A couple of words about Lightning Network. Who knows what is Lightning? Andrei doesn't know. I'll explain. So Lightning technology is a great technology which allows to scale any kind of public blockchain. So first of all, we use Lightning for Bitcoin blockchain, but in general, you can use it for Ethereum, you can use it for other public blockchains. But Lightning is not a separate blockchain. We call that Lightning is a second layer protocol based on some basic blockchain, for example, Bitcoin blockchain. And Bitfury with Elizabeth Stark, Lightning Labs, these guys created this idea of Lightning. We have been developing for 2.5 years this technology. It's open source technology. And also Bitfury team is working on applications. We call it set layer protocol, which allows use Lightning technology. And I do believe that Lightning will create a new big market of micropayments for all cryptocurrencies. So main properties of Lightning, you can provide, so it's a horizontal scalability solution, so you can achieve, I know, 100 million transactions per second. Transactions fees depends on a volume of transactions, so it's much less than 1%. That's why I told that Lightning creates a new market of micropayments. So for example, you will be able just to buy coffee or water with Bitcoins or with other cryptocurrencies due to Lightning technology. And for example, IoT, Internet of Things market, you will be able to provide transactions less than $0.01. All these transactions are almost instant, which is also very important for B2C market. And three more technical properties. It's decentralized solution, so everyone can join Lightning technology, not only like a user, but also like a hub or like a channel, and everyone can help to process transactions in this network. And probably one of the most interesting features, properties of Lightning, that if you have some Bitcoins, for example, or other cryptocurrencies, you can invest your Bitcoins into your channel. And if somebody else will use your channel like infrastructure, he or she will pay you fees in Bitcoins. So if you have some cryptocurrency, with Lightning technology, you will be able to earn cryptocurrency. And it's probably the only way how we can earn Bitcoins from Bitcoins without any risks. So if if you want to mine or if you want to trade, there is always risk to lose your money. In Lightning technology, you don't have such risk. So a few words about how Lightning technology works. So you see a network of like players, and there is a sender, there is a recipient, and there is a routing algorithm, and Bitfury created this algorithm 2 years ago, and currently it implemented in Lightning protocol. This algorithm finds the best way to process transaction. So how it works, and as I mentioned, Lightning has horizontal scalability, and that's why if you add 100 times more participants, you will be able to proceed much more transactions. That's why we do believe that it's a great payment system of future. So what is Lightning Pitch? Lightning Pitch is our set layer tool, which allow to decrease the barrier of usage Lightning technology. Because if you want to use Lightning, you should create channel, you should invest their Bitcoins, and it's not so easy, and probably it could be a problem of motivation why people should do it. So we built a system which will increase and boost Lightning adoption and Bitcoin adoption and cryptocurrency adoption in particular. We launched the information, you can find the information about this tool on lightningpitch.com, so you're welcome. So a couple of words. We have several applications. We have SDK for developers. And as I said, we create a tool to motivate participants to start use this technology. And I will pass the word to my colleague Andrew. As I mentioned, there is, as I said, challenge is data availability, and Andrew will share how we are going to solve this challenge.
Hey guys, yeah, let's just give a round of applause to Alex, and thank you for the presentation. As Alex mentioned in the beginning, data on the blockchain, especially when we talk about public blockchains, is quite an issue. And I will be focusing on public blockchains. So let's just begin with the presentation. When we see the data in the blockchain world, we can easily understand that blockchain world is quite ordered and structured, right? We all know that blockchain is a very structured thing, and it's powered by cryptography. We know that transactions are being validated in Bitcoin, are validated by miners, as in Ethereum and so on. Blockchain is really a nice place, but the problem is that there is not a lot of data on it. And when we talk about the data from the real world, like external APIs, payment processors, even I can say that even like getting a random number on a blockchain such as Ethereum is not really a very easy thing to do. And we have a lot of data sources, and those data sources, they have some shared standards like JSON, XML, and so on. But the structure of the data is just not there, right? So, and also, what we don't really have in this world is a verification of what data is sitting where, and what are the guarantees of this data to be valid, and so on and so on. So the next thing I want to be talking about, I'm going to be talking about is an oracle, right? This is quite a common term for a data provider, which is sitting between the real-world data and the blockchain. This is quite a common concept in blockchains such as Ethereum. There is a number of Oracle solutions out there, and we are going to explore more what those solutions are and how can we think, segment, and kind of categorize them. We introduced the concept of an oracle, and the next thing that would be quite important is for us to introduce the concept of trust. Trust is not something specific to a blockchain world, right? Because we, as people, we have something that we trust or not. But I'm going to be focusing on the blockchain world for this specific presentation. So the first level is what we call a naive level of trust. And this guy, he just trusts everyone, whatever anyone says. There is no guarantees at all, and there is a lot of risk if we can think of this world. There is a big risk of something being wrong. The next level is what we call a faith. So a lot of current implementations of Oracle technologies are actually falling into this category. And they're quite common and quite easy to implement, right? So you can have some centralized solution just pushing the data on the blockchain. And when you use this data, what you have to do is you have to have faith or to believe that the data that is on the blockchain is pushed by the source that you trust. The next level is the level of doubt. And this is probably the most populated category of Oracle solutions on the market today. Such solutions can be characterized as decentralized and much more resilient than a centralized solution, only because they don't have such things as single point of failure and so on. Also, there is two large subcategories of solutions of this level. The first is a humankind solution, and sometimes we can refer to them as the word of wisdom solutions. For example, things such as prediction markets are falling into this category. And those solutions are highly scalable, right? We can incentivize a lot of people to participate. They are resilient because of the scale. But there is a couple of problems in solutions of that kind. And probably the first and the biggest is the speed and the cost, right? Because if we talk about a lot of people predicting something or talking about a specific topic and giving their opinions, it would take us a lot of time to collect their opinions, to collect what they're going to say, process that, and put it to the blockchain, right? Also, when we talk about such systems as expert opinion type of oracles, it just could cost us a lot of money when we are asking a lot of experts to have a vote on some piece of information or give us their opinion on that. Another large subcategory of oracles of that kind is a machine kind oracles. And this is more about things like Internet of Things, sensors, and stuff like that. So those are as well decentralized and resilient. The speed of processing is much higher, right? And however, it is quite, it takes a significant effort, a significant investment to build larger networks of say, sensors pushing the data to the blockchain. The next level that I'm going to be talking about is the level of assurance. And basically, what we talk about here is that we have some kind of a trusted root authority that have a lot of stake in the way they provide the, say, certificate or some kind of a proof that something is has been given a license or whatnot, right? What stake could it be? It could be, for example, an SLA. It could be some legal obligations leading to some kind of some consequences if the obligation is broken, right? In terms of oracles and the blockchain, we are seeing a lot of movement in that direction. However, when we say that we have some kind of a single authority, this is not that kind of thing you really want to have on the blockchain, right? Because this is a centralized, and this is something that you have to trust, and this is an authority. So, but still, this is just something a little bit on a higher level than the previous type of solutions. The next and the last is something that we call a certainty. And this guy is definitely certain what he sees. And here we speak about things that are backed by physical properties of the device pushing the data or processing the data to the blockchain. And here we talk about things like HSM, which is hardware security modules, right? And you can see those type of modules, for example, in a typical ATM machine. But we don't really have ATM machines, at least on a large scale, pushing the data to the blockchain yet, right? So this is an important thing because it is really hard to break. And when we talk about the data that is backed by hardware, we also see a growing number of solutions on the Oracle market, basically allowing you to run, to have a piece of data, run a secured computation on top of that, and put this piece of data back to the blockchain. This is especially important in areas such as identity, obviously, because what I'm actually I've been talking to a lot of people on this conference, and a lot of people are talking about hardware solutions to an identity problem, right? Health data is significantly important because you don't really, you have to be certain that your health data is secured and not being tampered with. So we've discussed a little bit about what levels of trust and what Oracle solutions are there on the market or going to be on the market. And let's talk a little bit about what is coming. And the first thing that we really see as an emerging kind of movements in the industry is truly decentralized data sources, cross-validation between multiple data providers using some kind of a statistical analysis, for example, validating that this specific API that is being processed, the data from that API is being processed, cross-validated, statistically analyzed, and then put to the blockchain. The next important thing is that we've seen more and more hardware-backed oracles. Especially, we've seen a lot of movement in such areas as weather data, health data, IoT-powered sensor data, such types of things. And as those technologies are becoming cheaper and easier to use, we will see the number of those oracles are going to grow further. And the last but not the least is the private computations on the public blockchains. And this is something that is not very trivial, right? Because when we talk about public blockchains, everything's public, right? And there is a number of areas that we really want to have a secure computation. We might say that financial kind of transactions between some parties, we want really to have them secured, but we still want to have them on the blockchain. Calculations on the health data is an extremely important, and it's a good example of those. And we can imagine like a number of different approaches when those will become useful. So I don't really have a cool slide as Alex had about the solution we've been building for 2.5 years, and here we go. But what we currently do is we are doing a lot of research in that space. We have a bunch of prototypes, and we have a bunch of software of a better quality. So if you are building some decentralized applications, if you are interested in putting the data on the blockchain, especially on public ones, I encourage you to talk to me, to talk to Alex, to talk to our guys at the booth. And I guess that's it for me. And thank you guys for your attention. And we would love to have any questions.
Are there any questions here in the room? Here, can we
Yeah.
get the microphone?
Hello, my name is Anar. I have two questions. Can I ask for
Go
two
ahead.
questions?
Yeah.
Okay.
You're welcome.
One question for Alex. Do you help another project, another blockchain to implement Lightning technologies, or it's only for, I don't know, for using inside the Bitfury?
Yeah, all our solutions based on Lightning are open source. We implemented already Lightning on Bitcoin and Litecoin. So if you have some solution and if you're interested in Lightning, you're welcome. You have my contacts. You see my contacts. You're welcome. We'll discuss it.
Okay. And the second, I didn't understand what the difference between software-based oracles and hardware-based oracles. It's not trusted oracles, yes? It's centralized oracles.
So, the question was if there is a difference between software-based.
Software-based,
And
hardware-based, what's the difference? You are focused on the hardware-based oracles. I don't understand what the profit.
Why do we think that hardware-based oracles is a growing trend? Because the data is validated. It's a combination of software and hardware that's providing guarantees that the data is valid, right?
So, wait. So, but they still centralize it, yes?
There are both centralized and decentralized solutions for both software.
I don't know that there is no any theoretical solution for trusted oracles. They are not trusted oracle, yeah?
Okay,
they are
cool.
not in blockchain.
I think I can give you some examples, and we can discuss it when we finish.
Okay.
So there's a bunch of different companies doing different type of technology, and I can give you just a bunch of examples, and we can figure out like what solution is interesting, specifically for your use case, right?
Deal.
Cool. Thank you.
I think we have time for one. I think we have time for one more question. But
think we have
before
one
we are
on
going
the,
to the next question, I would like to remind that at the moment there's a workshop happening upstairs from Voltora about private keys, as I said before. So if you want to join that workshop, please go upstairs now. There was one more question here.
My question is to Andrew. If you can compare and contrast Exonom solution with a quorum solution that is based on a fork of Ethereum, and it's also permissioned with a proof of authority. I understand that Exonom is a proof of lock, so maybe you can compare and contrast these two solutions.
Exonom is not a. Exonom doesn't use the proof of work algorithm. Exonom uses something that is called a BFT consensus algorithm. I'm probably not going to go deep into the Exonom implementation. I'm not sure if that's a good idea to compare a system using proof of work algorithm and a system that. Sorry, which one is using the proof of authority?
About quorum. Quorum is not using proof of work, it's using proof of authority.
Yeah.
It's a fork of Ethereum that removed proof of work and replaced it with proof of authority. You're using proof of lock. So maybe you can compare and contrast these two blockchains, like for the use case of a retail coin.
Cool, that's a very good question. However, I think it's, I mean, we can talk really a lot about differences. So if we just, we should probably just finish with the presentation, then we can discuss in private.
Short answer. Yeah, theoretically we can do it. So right now, for example, we built a bridge between Exonom and ERC20. The thing that you know that there are numerous of ICOs who use ERC20 token, and it's very good, clear technology. But the problem is that the problem of scalability in ERC20, and some of these ICO projects need a big number of transactions, and if Ethereum itself, like public blockchain, cannot provide so big number of transactions, that's why we offer to use Exonum for internal project, for internal system, and ERC20, for example, in Exchange. So we are working on building this bridge, and obviously we can consider this collaboration with other blockchain technologies and solutions.
Thank you. I'm sorry we have to go to our next presentation.
Sure. Thank
Andrew
you.
and Alex, thank you so much.